All right, welcome everybody. We are live yet again, and I've got some interesting, important updates I want to share with everybody. Part of doing this in public and building in public is I correct myself and I get better, and then I want to share what I've learned with people, report back. So that's what we'll be doing today. I've got a number of very interesting findings. Let me start with something that I was kind of kicking myself, but then at the same time, it was pretty awesome to see that I had this performance boost that I could plug into. So I have a graphics card called NVIDIA. Let me see. Let me just copy this. GeForce RTX 3060. I think it was like a couple $100. The reason I got it is because of video editing. It makes video editing way faster, and since I do a lot of that, as you know, that's why I ultimately got this card. Now, to anybody out there who is ever considering getting a graphics card, which I think these days makes a lot of sense if you're doing this type of research or work with neural networks, make sure that it's CUDA enabled, that it has CUDA. And I was lucky enough, I didn't even have that in my consideration when I was shopping for the graphics card. I think I just went off ratings, which of course, this is a factor in people's experience. But CUDA is a pretty awesome architecture built into the NVIDIA graphics cards. And basically it allows us, while we can do a lot of this neural network training that I'm going to show in a second on our CPU, it's pretty intensive. That's actually what got me to figure this out, how to offload it onto my graphics card, is my computer was just totally bogged down because I'd have these different training runs going. Like I've got, I guess, 2 training runs at least going right now, and we're streaming at the same time, and it's just doing it all in stride, which is awesome. But before I figured out how to put it onto my GPU, it was kind of capping my CPU to disastrous outcomes. So I wanted to show how I figured this out, because it's the exact same code, and it'll just use the CPU unless it has a CUDA enabled GPU to use. And what I ultimately had to do is, because I already had CUDA installed, but it was the wrong type of installation. I had the toolkit 12.3. I had to uninstall that. Then I installed 12.1.1. For some reason, that's like the latest one that you can use with, it's called PyTorch CUDA. So I uninstalled my other Torch that I had installed, which was CPU based. And then there's this command here. If anybody needs this, just send me an email. Pip install Torch. You probably don't need Torch Vision or Torch Audio. And then the index URL, you have to specify. CU means CUDA. There's also CPU, which is CPU. So that was a big breakthrough I had the other day. And I was kicking myself because I thought I had been using my GPU. I'm like, shoot, I've been wasting all this time. And then I was like, wait, that's actually pretty awesome that I've gotten used to using my CPU and then just offloaded it onto my GPU. So just wanted to share that. Make sure that you're using the right version of CUDA and PyTorch to enable this. So what have I been working on? Well, I've actually had a number of breakthroughs, and I attribute a lot of it to being able to visualize what I'm doing. That made a big difference for me. Like I previously tried to spin up some data sets that weren't very meaningful to me. And then the loss, whenever you're training a machine learning model or neural network, you see the loss here. You want that to be as low as possible. And if I scroll up here, you see that the loss has been decreasing and decreasing and decreasing and decreasing. So it helps to have meaningful data, and especially as a sanity check. So what I did is in 2 and 3 dimensions, I wanted to be able to generate data. And by the way, I'm going to be publishing all of this to people who support on Substack. It just takes $5. You can unlock all my premium stuff. Cancel whenever you want. Take the code and run, as they say. But I'm going to keep publishing code for supporters, because that's one way that I can keep this channel afloat, maybe. And I'd love to put it all out for free. In a way, I'm teaching you everything right here, minus all the code. But you can easily do what I did and use ChatGPT. Like their 4.0 model is really impressive, honestly. And I believe it's free too. I'm a paid user, and I very rarely hit the cap. If I use a lot of GPT-4, I'll have to hit the ceiling, the cap they put on it. But with 4.0, they give you a lot more queries, and you can generate whatever code you want, and it's pretty straightforward and easy to do. But that's $20 a month to be a pro, and I'm giving all this code for just $5, and then all the other BERT code as well for text classification. We've talked about that before. So this is kind of like an outline of what I'm going to show here. It really helped me to be able to visualize it, both on the data creation side and then on the prediction side. So a little sneak peek here. This is the prediction side. We can see the blue is the model's prediction in 3D space. So the inputs are the X and the Y. You can see at the bottom of the screen here, the X and the Y axes. And then the Z, the green dots, are the actual data points. And the blue is what the model's predicting. So it does pretty well. You can see the corners are a little bit off. And then down at the bottom here, the blue mesh doesn't go quite as far down. But I haven't trained it extensively. Like, I'm still kind of in the embryonic playing around stages where I don't need like a perfect model. It's more like, what's the fastest way to train a model, and how far can we go? How, just what are the capabilities, the faculties of this technology? So I have two scripts here, or HTML files, which is a great way to do visualization stuff and data wrangling. And ChatGPT helps us write this code. I don't mean to make it like an advertisement for ChatGPT, but it is hands down one of the best tools that we have if you're at all interested in this kind of work. It's like really crazy what they've come up with. As much as I hate them, I'm looking at like, okay, just as far as deals go, $20 and I can get all this code and more. That is something that personally I'm like, okay, I'll do that deal. So then we have the two-dimensional equivalency. So basically the way both of these work is I have the minimum X, maximum X, and then for the 3D I also have min and max Y. And then I can put the equation in here using JavaScript. And then I have a number of buttons here that I can just click, and it makes me whatever that function is. And so what's great about this is I can make curves, mathematical curves, then I can export the CSV, or what I tend to do is export the shuffled CSV. And then I can use that as an input into training these neural networks. So I've gotten to a pretty good place after iteration after iteration after iteration, trying to figure out what's going right, what's going wrong. And so that's what I want to show today. So this is just an example of the visualization of once I run a model. Once I train a model, one of the things I do is I print out a CSV. So it takes in a CSV for training. And let me just show you kind of what those CSVs look like. So this is a three-dimensional CSV input. The X and the Y are what we call numerical features. Features are what the inputs are. And then we try to guess. I mean, I guess you could say this is the target feature at the end, but we have input numerical features. Those are X and the Y in this case. And then we have the output, the target, which is Z. So the idea is, in the wild, we might not know Z, and we want to be able to guess Z. So maybe Y would be our target sometimes. Just think about, we're trying to make predictions. And so the prediction is what we won't know in the future. That's our target. In this case, Z. And the two-dimensional stuff is even simpler. That just has X and Y. But that could be anything. A classic example would be height and weight, just for example. So once the model is done training, what I do, and I can just show the code here. Once the model is done training, I think it's this file, I have it save off a CSV with basically all the inputs plus this additional column, which is the prediction values. So I can just show, this screen right here is this data set. Actually, sorry. That's wrong. This is from something else. This is from the animated training graphic I'm going to show you in a second, which is pretty cool. Ah, shoot. How did it get so wrong here? Get JSON. Wow. Okay, I'm just going to undo that. I think I just pasted it in the wrong spot. Okay. So that's right. So if we open this up, you can see we have X, Y, and Y predict. So you can see the predictions are pretty close here. But what's much better than trying to like scroll through here and be like, oh, look, that's pretty close, that's pretty close. Let's just view it on a graph. So that's what this is here. And this wasn't even trained too much. I could train it more and more and more. That was one big breakthrough. I almost gave up because I was running these with like 100 epochs is what it's called, which is like how many training runs do you do? And I was like, oh, it's not converging to the function. These things are terrible. And then I realized, oh, well, if I just turn up the number of epochs, which is especially helpful if you have a GPU that helps you accelerate this process, which I had, but I wasn't using, as I talked about earlier. Then you can really do a bunch of epochs and you can see it converge. So let me show you that. So this is a pretty cool script that ChatGPT helped me write. I mean, it's seriously increasing my productivity by tenfold. And what's cool is it's also a neural network. So we're making neural networks, training neural networks with the help of a neural network to write the code. And then when it's time to do the live stream, I use a neural network to make the graphics. It's really an impressive technology. And I pretty much hate ChatGPT as a company, OpenAI that is. But as a product, I've got to say it's pretty impressive in some aspects. Now, there's a lot of like really bad information in there, sure. Okay, so let me show you this. Basically, I trained a neural network over not even too long of a period of time. And I took a snapshot every time it got 10% better, at least 10% better. So I didn't take a snapshot at every stage, although that might be kind of interesting. I just wanted to kind of simplify the data a little bit so I could load it all in. But you can see here's how it starts. The blue is the predicted line. And then every snapshot, when it gets 10% better, you can see how it converges here. So it's definitely learning. And to be able to visualize it is a huge help for me. This lets me have confidence, and I wrote all this code to be able to handle tons of input dimensions. But obviously we can only see in 2 input dimensions. I should also mention the architecture here. So with neural networks, we can design them in a whole host of different ways. Like this is one with 3 inputs. This isn't actually the model that I use, by the way. I'll tell you what I used in a second, but this is just an example with 3 inputs, then 3 hidden layers of 128 neurons or nodes, 64 and 32 respectively. And then it all converges to a single output node. So when you see something like this, usually we're doing regression, where a number is going to flow out the other side. So numbers flow in. All of these lines are like mini, basically linear equations. And then it all flows out the other side. So I want to talk more about this chart and the mathematics behind it in a second, because it took me a while to wrap my brain around it. But what I wanted to say first is, for all of these examples I'm going to show, including these 3D examples, the neural network architecture that I did was just one hidden layer. So instead of the 3 hidden layers here, there's just 1 hidden layer. And that hidden layer had 1,000 neurons. So 1,000 neurons in 1 hidden layer. So 1 input node, actually, for the 2D stuff, so stuff like this chart here, just had 1 input, the X. That's what's on the bottom here. The X flows in, then the Y value flows out. But then for the what I call three-dimensional stuff, probably not the best term, but 2 input dimensions and 1 output dimension, there are 2 input nodes. So let's talk about the math here a little bit. I think it's super interesting how these neural networks are basically a combination of a bunch of small, simple mathematic functions. It's pretty much as simple as the line equation they taught us when we were kids. Y equals mx plus b. It's just y equals mx plus b all over the place. So let's take this for example here. And I know it's a little annoying that I've got to scroll up and down, but it's a large graphic, so just keep that in mind. We have 3 nodes on the left, 128 nodes here, 64, 32, and 1. Now it's interesting, the way this is actually represented in code is different. In code, what we say is there are 4 nn.linear structures. And I'll show you this code. Let's just look right at it. So this is a little bit hard to read because it's a loop, because I want to be able to support all different types. And this is kind of a general function here. Although at the same time, let's queue up ChatGPT and say, give me the PyTorch code for a neural network with 3 hidden layers, 128, 64, and 32 neurons respectively. So give me the PyTorch code for a neural network with 1 input, or let's do something a little bit more complex. Let's do 3 inputs. And there should be, let's say, 2 outputs. So what we're going to see here is there's actually going to be 4 nn.linears, which is a little bit confusing when we first look at it. But it makes sense. It's just kind of not at all how we draw it. It's actually the space in between each of these rows is what we call the nn linears. So the first one, nn linear 3, 128. That's between, I kind of visualize it as a line halfway between these white dots in the first and second columns. And these parameters here, 3 and 128, that's 3 on the left, 3 inputs, and 128 on the right. Then the next one, 128, 64, that's the space between these two. 128, 64. And then this one here, 64, 32, again, the space in between here and here. And our examples are a little bit different here because I have 1 in this and 2 in the other. But you get the point. So I find this to be interesting to see how it's actually implemented. Okay, so what's the math here, if you're wondering? The math is that there's a connection between every single one of these 3 or 128 or 64, whatever number's on the left, and the number on the right. So in this case, you multiply these together, so whatever 128 times 3 is, 384 connections. And then here even more, here even more. And so for every one of those connections, there's a weight, which you multiply whatever's coming in from the left, the input, there's a weight that gets multiplied. And then for every output, there's a bias. So the equation y equals mx plus b from elementary school math becomes y equals wx plus b, where w is the weights and b is the biases in matrix format. And then what's also interesting is the y and the x are also matrices in this example. So it's linear algebra. That's what it's called, linear algebra. So what we can see really quickly here is that for each one of these linear layers, there is going to be matrix multiplication and then some addition. But it's pretty cool that what is visualized like this to our eyes, to make it, somewhat make sense, is really just 4 matrix multiplication and then additions. So it can happen really fast, especially with something like a GPU from NVIDIA. And again, I don't like these companies at all, but I'm just saying NVIDIA is kind of probably through a lot of unscrupulous business practices way out in front in the GPU game. And you can see here, this is pretty interesting. I saw this right before the show started. It's all under 3D graphics category. And that's more of a historical fact. There's historical reasons to that, because a lot of this technology arose from people playing video games and buying these state-of-the-art graphics cards. I always thought these people were wasting time and just a big waste of money. People spinning up these super powerful computers just to play shoot-'em-up games. But actually, that is kind of how this whole thing happened. 3D graphics, 3D rendering to make the video games possible. And then people playing in real time, needing the real-time 3D graphics, which involves a lot of matrix multiplication. So for whatever reason, they're calling matrix multiplication 3D graphics. So what's also interesting is there's a whole other category of processors. So there's CPUs, which kind of are multitaskers and can do all sorts of different things. Then there are GPUs, which are a little bit more fit for this purpose. But then there's something called TPUs, or tensor processing units. Tensor processing unit. And these things are just really good at multiplying matrices, from what I can tell. And a tensor, I actually don't know let's see what's the definition, or what's the difference between, I know like a list is a tensor, but I don't know, let's see, are matrices tensors? What is the definition of tensor? I know it's kind of a sidebar. Yes, okay, matrices are a type of tensor. Okay, so basically tensor processing units are matrice processing units. All right, so just that was just a little bit of math behind it, because it's interesting. We don't have to really think about that math, but it can be used to very quickly take a huge batch of inputs. Like, for example, when I'm training my data, going back to this, ignore the third column here, but the first two columns, 10,000 rows get put into a single matrix and fed into the neural network. And then if we have, for example, in the example that I've been doing, 1,000 nodes in a hidden layer, it's going to do two matrix multiplication steps and then matrix addition steps. And then you have predictions for 10,000 Y values. Actually, that's a bad example. I misspoke here, because really in this example, I'm only feeding the X values in. 10,000 X values predicts the 10,000 Y values, and then we compare it to these. But for the additional dimension, it's what I said before. So I find that to be very interesting how they've gotten this down. And then the really fascinating part, and I can't even pretend to understand the math behind this. I'm sure if I sat down and tried to figure it out, look, I've seen people do it on YouTube with Python, where they do what's called backpropagation. And that's very easy to do in PyTorch, or TensorFlow, which are the two predominant ways for people to spin up these neural networks. But you can see right here, this step right here. So first it's actually pretty interesting. So this is how the model's trained. Let's go back to that ChatGPT example that I had, since this code is awesome because it's so flexible and it'll take whatever dimensions we throw at it, any CSVs that we have that we want to throw at it. But let's go back to this. This is a better example. So this is the code we were looking at earlier. Here's how it trains. Actually, I'm not sure if this does the... Where's the... Can you give me the code including loss.backward? Okay, here we go. So this calculus that I'm about to tell you is all just a one-liner in the code. So the way this works is we have these different steps of the process. The forward function is what actually carries out the processes. And then ReLU is like an activator function. It just kind of manipulates the values. So I guess it's a little bit more complicated than what I just mentioned, because there's a step to kind of activate the neurons, as they call it. But basically it says x equals FC1x. So that's doing the matrix multiplication in the bias addition. And then again, for step 2. So x keeps flowing through and gets replaced, right? X equals the matrix multiplication of x through our weights and the biases in the first neural network. Then x equals, again, we run this second function. It's a linear transformation, matrix multiplication and addition, and then we reset the x. And then the third, x equals the third linear transformation, matrix multiplication and addition. And then finally the fourth. And then we return x. So this actually gets run one time. You can have a ton of different data points in your batch, and it all gets done in one fell swoop. And what's interesting is this forward function gets called during both training and when it's time to use to make predictions. And so down here, this is the training loop. So epoch is just kind of this main loop that we use. So what's happening here is we get the output from the model. So we give all the input data in a matrix format, give it to our model. It does the math that we described. Then it can see how well it did, because it has the actual values, because we're training. If you don't have the actual values, you can't train. So then we can see, okay, we did pretty good, or not very good. And then this is the magic step right here, for lack of a better term. Loss.backward. And so this is backpropagation, and it uses whatever your optimizer is. So the two major ones that people use, this one's using Atom, and the other one is stochastic gradient descent. There's a few others, but basically that's how these neurons get adjusted based on how well the prediction does. And there's some really smart math going into how do you tweak these parameters, given what you learned about. I gave it all my input. I saw what it gave out. I know what it should have told me. How do you improve the model with all that information? And so it does some calculus that I don't understand. But basically it's tweaking all the knobs and the dials. So we're going to get to some examples here in a second. But what's interesting to me is to think about all these different options we have. Like, how do we want to structure our neural network? Do we want to have just 1,000 nodes in a one hidden layer? Do we want to have a bunch of hidden layers? When does it make sense to add more neurons? When does it make sense to have fewer? When does it make sense to add more layers? When does it make sense to not, or to have fewer? When does it make sense to use Atom? When does it make sense to use stochastic gradient descent? And this isn't something that the average viewer out there has to worry too much about, but these are interesting questions that emerge. And what's really important to keep in mind throughout all of this is exactly, well, not exactly, but this is the same type of technology that's being used in, well, I should bring up the transformer stuff. I don't really understand transformers particularly, but they're a step up over this, which is called a feed-forward neural network. A transformer is really good for sequential data, for example, text, because it's not just a bunch of numbers that we're feeding in. It's words in an order. The order matters in speech, obviously. So what's interesting is whenever the math improves, or if OpenAI or anybody else can find some new tricks of the trade, I mean, I think we're in for some crazy times ahead in terms of just massive technological improvements as people iron out this technology and figure it out. So I thought this was pretty interesting, speaking of this, just to give us an idea. I've heard people speculate that GPT-4 is a fully connected, dense neural network. And this, from an NVIDIA presentation, seems to say that it's a 1.8 trillion mixture of experts model. So 1.8 trillion parameters, which I think would include the weights and the biases. And remember, for every layer you have, there are all the connections. So a layer is different than the hidden layers. The layer in this sentence that I'm saying, the layer is in between each of these visible layers to us. So in this case, 1, 2, 3, 4. And then for every one of those, you have the number of ins, the number of outs, and then between each of those ins and those outs, there's a connection and a weight for each of those connections. And then for each of the outs, there's a bias. And then if you add all of those up, and I think I have a calculator somewhere for this. I'm not even sure if this math is correct here, but let's just see. If there's 3 inputs, 1 output, and 128, 64, 32, 10,881 trainable parameters. So OpenAI is dealing with a much, much larger model. And I believe they're using transformers. That's the whole point of GPT. Stands for Generative Pre-trained Transformers. We've also talked about BERT before. I'm just so blown away by BERT. Again, I have some awesome code on Substack. More to come on that front. So if you want to support the channel, get some awesome code, not have to spend all the time that I did putting the code together, just leverage what I've done. Just go to Substack. And if you're a supporter, you can email me. And if you have any trouble running it, just let me know and I'll be happy to help. But BERT is pretty cool. It stands for bidirectional encoder representations from transformers. And then there's something called DeBerta, which I've heard great things about. I haven't really tried. Which is like Microsoft's taking it to the next level, apparently. And these are all really easy to use, especially if you just download that code on my Substack. All right, so what else can we show? We've looked at the animated training run here. Just a little example of how a 1,000 node neural network can very quickly figure this pattern out and fit this line. But what I was very interested in is, okay, how does this transcend? Okay, like a single line it's interesting, but what about 2 dimensions with more complex shapes? So I tried this one. I think this was maybe this. No, it was, takes a second to load. This one's a pretty cool curve. That's not it. Maybe this, cosine x times cosine y. It might have been this, and then I might have changed the min x and min y, but... And I do want to try into the future even more complex curves like this. But there is a theory, or a theorem, called the universal approximation theorem, which basically says that any continuous function can be represented by a neural network with a single hidden layer. So I was, you might have remembered, and that's one reason why I'm doing this stream. I'll put out another video just with the how to train a neural network with a link to the code. But I said the other day that I was finding these neural networks very frustrating, very finicky. Now my opinion's totally changed. I'm blown away by what these can accomplish, and I've seen time and time again with transformers, diffusion models, and feed-forward neural networks, which are just these simple neural networks. They can achieve a lot of amazing stuff. And one space that I just haven't seen too much on is just doing regressions, which is predicting a number from a number of features. And so I just wanted to hammer this out, and now I'm pretty impressed by that side of the equation as well. So it's always good to write reusable code. So what I did here is, let me show you the runner. Basically, I wanted to make this as simple as possible to use. So I just made a class called Neural Network Trainer. I passed the path to the CSV. I tell it what my numerical functions are, in this case, X and Y. I tell it my target, which is Z. I tell it how many layers I want. So this is just a single 1000, but I could do the 128, 64, 32, just like that, super easy. A dropout is used to prevent overfitting, which is a problem. One reason why you don't want to just have a ton and like a massive number of nodes, because then it can just learn your data. Without actually, I mean, sometimes you don't want it to, it's kind of tricky. The ultimate trick is that you want to have a ton of data, which can sometimes be an issue. We talked earlier about, or last time, about the curse of dimensionality, whereby if you have a single data point, you're not going to be able to figure out what the big picture is. Like if this is the pattern and I give you one data point, what are the odds that you can say that this is the shape? It's probably not very likely, right? I couldn't do it. Nobody can do it. How many points do you need to be able to figure out that this is the shape? And it turns out the number of points increases the number of dimensions that you have. So you might sit back and say, well, I'm certainly going to be able to train a good model because I have 10,000 features, and I just have to predict this last feature. Well, you're going to have to need a ton of data if you have 1,000 features. As the features go up, the space goes up. Think about the difference between an X and a Y chart versus an X, Y, Z chart. The volume has increased substantially. And so too does the amount of data to be able to see like what the continuous function is. So that's where feature reduction, feature elimination comes in. So there's like the whole art to this. And one of the most interesting aspects of it all is the language models, which I don't even know if I want to build from scratch. Probably not. Although I might be kicking myself at some point for not doing it. But there are a lot of companies doing language models and putting out these what are called base models that you can fine tune. And that seems more interesting to me, to fine tune the language models versus trying to spin one up from scratch. And you can get them to drift a pretty long way. But then I see OpenAI out in the front, and I feel like what they're trying to do is what YouTube did in the early days of video on the internet, where they're trying to gain all the market share and basically just suffocate all of the competition, or would-be competition, make it impossible to compete with them. That's what I see OpenAI doing. So the game theory analysis on my side is like, well, maybe we should just use OpenAI and just try to extract as much as possible from them, especially in the form of information and code, knowledge and code. I'm not saying that they're like a perfectly, this is an understatement, but obviously I'm not saying they're a truthful organization or that their model is truthful, but there is knowledge baked in there if you know where to look. Just like on YouTube, if you know what channels to tune into, you can get a lot of very, very useful information. All right, let me go back to this outline. This is all the code I'm going to be putting out to supporters on Substack. Just $5 gets you all this stuff. Haven't published it yet, but look out for it in the next couple days. Especially because I'm going to try to get this out before when I expect GPT-5 to come out. I'm predicting it. I think it's going to be on 6/6. They're going to put out GPT-5. And there's a number of reasons for that. But the more I think about it, the more I think they're going to do it. I hope I'm wrong. These are my favorite types of predictions to make when I hope I'm wrong. Because then it's like, well, Tim, you got it wrong. Well, I hoped I was wrong. So I think it'd be a pretty bad sign if it comes out on 6/6. I don't think that means it's going to be a bad model. I think it's going to be very, very powerful, world-changing. But just for them to choose that date. Also, keep in mind here the different numerologies or the different numbers that we keep seeing around this organization. Their logo has 6, obviously 6. There's a hexagram in the middle and 6, almost 6 looking things. 6 sixes. But think about the size of their model too. I showed this earlier. 1.8 trillion. What's 6 plus 6 plus 6? 18. What did we see today? That was a totally manufactured news story. Berkshire Hathaway stock crashes 99%. Of course, it was just like a display error, right? They said, oh, no, it didn't actually crash. You can't buy it at 1%. It's just, we just wanted to run this big news story, right? I don't know. When I see 99% drop, down 99%, and then we're all looking at 6/6 as being this date, 24, no less, which sums to 6. Just keep this in mind if they drop something. I hope I'm wrong. It's also interesting on this slide from NVIDIA. 1.8 trillion mixture of experts model. So if you don't know what mixture of experts is, basically you train different neural networks to be specialists or experts at certain fields, certain areas. And then when a prompt comes in, you give it to the appropriate expert instead of just one massive network. But what we can see here is 10 days of training, which is interesting that they say that, because that doesn't seem like too long for these models to be cooking, right? So just keep that in mind. They can train these up in 10 days. I mean, they have so much compute. And NVIDIA is bragging that they have these new chips coming out. This last one here, Blackwell. These behemoths. And, the whole energy thing is another big topic that I see obviously getting shoehorned in here. I see in the future there being energy rationing or just possibly through price systems of control where they price it to where people have to ration. And then they're going to say, oh my gosh, the climate's changing unless we use the AI to decide what to do. And then they're going to say, oh, we have to give all the power to the communists and clamp down. Right? So obvious, transparent bullshit. Right? It's so obvious to see. So I'm certainly against all that. I'll be calling that out and going against it tooth and nail. But that doesn't mean I'm not going to use ChatGPT just like I use YouTube. You know, we all use these things when they give us value. Although in a way, these are all akin to like a rat trap or poison bait, the lure on a fish hook. So be very careful with all this. All right, let's see what else. I don't want to ramble too long here. I think we've done a pretty good job of summarizing where we're at. It's really helpful with these language models to have reusable code, to have a way to visualize and have a data set that you can actually see and that it has some meaning to it. Like this is a pretty complicated data set right here, right? I haven't really tried a model on this. I will. But it gives us hope that like, okay, if we can train on a model like this with all these peaks and valleys and it can learn this, then that gives us some hope that it can learn our data sets and give us predictions into the future when we need it, right? And I've already been impressed at how quickly it converges to something like this. So I think it will do just fine. This is another one. I didn't even train it too long. This was like a couple hundred epochs, I think. And almost, I mean, it's a little off for sure, but this one was a weird one. I don't even know what this function was doing, but other than like these points somehow getting way down low and the blue predictions not quite conforming all the way down, it's interesting that I can learn this shape as well. All right, what's my point? So it really helps to visualize. It really helps to have data sets that you know have some meaning into it versus just using ChatGPT to generate a CSV, which I tried initially. Not the best way to do it. It's cool also to have animations. I want to try to do this with the 3D as well. But to be able to see how these things learn and how they converge, very helpful. And like I said earlier, having these reusable code bases makes all the difference. So I have these two blocks here. Let me just explain these. The first one here starts from scratch. Also, the learning rate is an important parameter. The higher you set it, the faster it'll find the pattern. But there is a catch. Sometimes if you set it too high, there's issues. It'll skip over what you're looking for or just go off into the undefined territory. But then also what I wanted to be able to do is load these models back up. So whenever I train a model, it's going to save off what's called a PTH file. But I made sure to store all the key parameters with the PTH file so that we can just load it up this easily. So we just take a path to the model. So say we cooked it for 10,000 epochs. We pull it up here and it's like, oh, that's pretty good, but let's see if we can get it even better. Let's run it for another 10,000. That's what I meant to show up here. Then what you can do is basically point at your existing model, point at your CSV for training. Again, specify the input numerical features, the output feature, the target feature that is, and where to save the model, and then just run training with however many epochs you want to do in the learning rate. So this opens the door for a lot of neural network training. So I'll be putting this code out there. Thank you to the supporters. Also, if you support on GroupDiscover.com, just send me an email. I'll be happy to send you any of this code for your support. And I want to have a way at some point to have some like downloads that everybody gets just for being a member on here. That's not hooked up yet. Also, just a little plug, GroupDiscover.com is a great website. We're looking for more researchers to join us. Whenever you find a video, if you're a member, a researcher member, you can just click new video, paste a link in, hit share. The best videos rise to the top. There's suggestions based on the group's ratings. And whenever I find stuff in here, or whenever I find stuff on the internet, I share it on here. So there's tons of like really informative material for people who are trying to figure out this transformative technology. This is like world changing. And I think it's a great opportunity if you have a job to impress your coworkers and maybe get a promotion because you're throwing so much more intelligence at your company's problems. So again, let me point out we have a 50% off deal. Anti-poison is the coupon code. When you sign up, 50% off. It goes a long way, and you get all this code. Just make sure to send me an email. All right, so let's see what else is on this list. The code base is important. The visualizers, the animated stuff, and the samplers. The samplers are a big part of it. So let me know if there's any questions in the chat. Let me read the chat. Shout out to DPFX for joining. They want more than a financial reset. They want a complete reset, DNA reset. I don't know what a complete DNA reset is, but there is certainly eugenics and depopulation campaigns. And I've pointed this out a number of times. I'll show it again. Let's go to depopulate. And I also publish a lot of research on Substack. which you'll get straight to your inbox. I don't spam or anything. So this is one that I'm working on that I wish I could get to the finish line, but there's a lot to it. But look here, this is the American Eugenics Society document talking about how their purpose is to bring about an improvement in the quality of the human race. Guiding principles. Knowledge about human beings has not yet... Sorry, not showing my screen. Knowledge about human beings has not yet advanced to the point where it is possible to project the ultimate in a eugenics program. Present knowledge is adequate, however, to make possible certain basic conclusions for immediate application. So what do you think these people, these evil bastards, are doing at the tippy top of the pyramid with this technology? What do you think they're going to do? Well, selective breeding, deciding who to sterilize, potentially mind controlling people, certain people into not having kids, mind controlling other people into having more kids. Take, for example, this quote, Julian Huxley, the first chairman of UNESCO. We must plan our eugenic policy along some such lines as the following. The lowest strata, allegedly less well endowed genetically, are reproducing relatively too fast. Therefore, birth control methods must be taught to them. They must not have too easy access to relief or hospital treatment. Hence the ivermectin sterilization campaign, which is one reason why I'm just totally, I know people are probably like, Tim, we like when you talk about medical freedom stuff. And yeah, the problem with that is it's a poison cult. It's a poison cult. They're just poisoning you with Saramin. They're poisoning you with ivermectin. They're poisoning you with what else? There's just a whole litany of these drugs they push. Many of them shut down the detox pathways. CBD, milk thistle, all this stuff they push for detox and as cures for cancer. Oh, that's another one. Fuck Josh Sigurdson and his cyanogenic apricot, or what are they called? Yeah, apricot kernels or whatever they are. Cyanogenic. And then always people pushing like zeolite and people pushing charcoal. It's like, yeah, just eat charcoal. Like, fuck you, man. I'm not eating charcoal. Oh, it's detox, man. It's the biggest fucking scam. And then there's people pushing drinking urine and doing urine enemas. I'm just so sick of it. And I'm like, I want to go on the opposite end of the spectrum from a bunch of moronic idiots over here. And they're really worse than that. I think a lot of people know what they're doing. And they're purposefully trying to humiliate and get people ostracized and committing social suicide and maybe actual suicide. And I'm sick of it. So I don't want to play into it at all. I want to expose all these evil people, all these evil agendas on both sides, including the people on the street corners with the syringes hitting up, if you know what I mean. I'm just so sick of all the drug pushing, the poison pushing. And then a lot of it too is psychological. And that's what we're really starting to see in the form of all these social media sites, is they can teach people to not have kids. Just to mentally make the decision to not have kids. And, the economy, like there's a classic image. Let's see if we can pull this up. Eugenics tree, right? People see this all the time, but they don't really think about what it says on here. Eugenics is the self-direction of human evolution. Look at what the tree that says eugenics, look at the roots. The key ones that jump out here are like law, history, sociology, economics. This is a huge one. Politics, statistics, medicine, psychiatry, psychology, right? So they're using all these things. Like the economy is a big eugenics program. All right, so I don't want to ramble too long here. I think I covered most of what I wanted to cover. A lot of it was just I wanted to correct the record. The other day I was saying that neural networks were finicky and annoying, but I think I have them under my belt now. Now there's this other type of input called categorical input, where, say if you're trying to, I hate this example. I wish I had a better example. Well, let's do, I hate all these. I was going to do guessing the price of a car, and the categories could be like two-seater, or excuse me, well, that would be one, 2 seats, 4 seats, 2 doors, 4 doors, has a sunroof, doesn't have a sunroof. Those are all categories. Be better represented as categories than as numerical values, I would say, or the brand of a car, the make of a car categories. The other one was movies. You could have like the genre, the major genre of a movie. That'd be a categorical feature. You can also have text embeddings. That's what text embedding means. You're embedding text into a neural network. And so that's where it gets a little bit more complex. What's interesting, though, is we can use BERT. As we've talked about before, BERT can give us a value in the predictions. So again, BERT's really good at text classification. So if you have a big list of, say, books, and you want to teach it what your preferences are to find what the best books are in the list, you can make a CSV either with a rating for each book. Say if you want to rate the books between 0 and 1 or 0 and 100, how much you like the book for a certain subset of the books, and then try to have it guess do predictions for all the remainder. You can either just say yes or no for each book or give it a score. And then you can have it predict for each book. Either you can just have it say yes or no. Is it aligned with your preferences? Would you be interested in it? Or you can have it give you a rating, which is cool because then you can say, oh, wow, this one is saying I should really check out because it's like a perfect score. So what's cool, though, is if we go back to the neural networks and we think about it, well, what if we had the yes value and the no value coming into the neural network? And then the final score is like the ultimate predicted rating for the book. But maybe you can have other numerical values that may or may not have some significance in the decision. So my point is, we have this issue that's called the curse of dimensionality. And that is that as the number of input features increases, the number of data points that we need to find patterns becomes almost impossible to satisfy. But we can, if we reduce the features, so if we take something that's, say, text, and we just use BERT to turn it into a score, yes or no, the yes score and a no score, well, we just reduced something that's thousands of dimensions. Like, let me see, what's BERT embedding length? 768 features, just from the BERT embedder. Or from OpenAI, they have their two text embedding models, 1,500, 3,000 features. So what we can do is do a feature reduction using BERT or DeBerta, and then the output, or then we feed it into a neural network with any other numerical values we have, any other categorical values we have. And then we get the best of both worlds, because then it's in the wheelhouse of the neural network, because you don't have the curse of dimensionality. You don't have 3,005 inputs, you have 7. All right, so that's the main thing I wanted to cover. I'm happy about this next release that I'm going to put out on Substack. I'm going to keep doing this, by the way, because I'm trying to practice using this crazy new tool that's like never been available to humans in the history of our species. And that is the large language model, specifically ChatGPT 4.0. I'm just blown away. And I think that they've demonstrated over their version 4 that they have some more tricks up their sleeve. And this is a smaller model, so I suspect the next one is going to be crazy. And I suspect it's going to come out in 2.5 days. So I'm going to keep writing code and trying to make it as useful as possible and help us master machine learning and AI and fill in all the gaps that I'm seeing out there. And I just love the possibility of putting that on Substack as a way to support the channel. And then people can just, pay $5, download all the code, and you don't have to use ChatGPT if you don't want. Yeah, I think that's it for today. I don't want to go on too long here. Let me check the chat, make sure I'm not missing anything. Not seeing anything. Oh, here's something on Rumble. Let's see. Yeah, people are going off about being upset at people pushing stuff, playing off people's cancer fears. It really makes me sick. And then, the parasite fears is another one. People always saying, oh my gosh, here's a cure for cancer. Do this. And it's like, you're just telling people to take poison and using dark psychology. I can see right through it. And then somebody will be like, oh, well, everybody has parasites, and here's how you cure the parasites. Drink this poison. No, it's poison. And they don't have parasites. You're scaring them. You know, because you've studied psychology, how to exploit people. Tell them they have parasites and cancer. It's like, I don't know how people can't see this. And it's pretty disheartening when you try to call this stuff out and you explain it really well and you expose the magician's trick, and then people don't come to your aid. And then they just send a bunch of sock puppets to thumb down your video, and it loses its potency. So yeah, it's frustrating, but I'm just gonna say, well, all those people are fucking dumb, and I'm just gonna let them, flounder like a fish flapping around. Let everybody see how stupid they are. The stupid eaters of the world. All right. I don't think there's any more comments. So thank you, everybody. I hope you all have a great rest of your day. Take care. Oh, I forgot to say, the Substack is timtruth.substack.com. Thank you.